Are you ready to do some grayscale testing with your laser? Then stick around, because that's what we'll be working through in this episode. Hey everyone, and welcome to another episode of James Dean Designs. Now in today's episode we're going to be taking a look at grayscale testing for your laser. Now there are a couple of reasons that this is important, and the two that I'm going to focus on is, first, it gives us a reference of power versus speed settings for future projects. We can just look at this chart and we'll know the answers without having to guess what to use in future. The second is it gives us a true scale of what to expect from the laser as well. The reason I say this is the diode lasers that come with these machines and other similar machines, they often start to drop off at the lower end of the scale. So if you imagine your grayscale going from 100% down to 0%, as you get down to the lower end, like 20%, 15%, you can often start to see that the laser stops engraving on your material. Now that doesn't mean your laser is faulty, it doesn't mean there's a software issue, it is just one of the downsides to these diode lasers. And it's worth remembering that on future projects. Now the first test we're going to be doing today is what I call a true power scale test. Basically what this is where we're telling Lightburn what power settings and what speed settings to output to, and this will give us an exact indication of what we should be getting from the laser itself, and that's also our reference for future projects. Now the second test we'll be doing, once we've done the first, is what I call a raster grayscale test. And this is where we're going to load an image into Lightburn and see how well it interprets that versus the power and speeds that we've already determined from the previous test, because it just gives us better expectations of what we're going to get out of this machine in future projects. Now the reason we're doing this in Lightburn is because if you remember a previous episode where I did it in laser GRBL, I didn't get the results I was expecting, and I actually later found out it's because Lightburn interprets images better than laser GRBL. So that's the reason we're doing that. If you're not familiar with Lightburn, check out my previous episode for going through the basics, but for now we'll move over to Lightburn and start to do this first grayscale test. So we're going to start by drawing one of the power scale grids, and I'll show you how to create all the settings to make this possible. Then I'm going to show you a tool that produces them automatically. The reason I'm showing you the manual way first is because it's useful to know, and it also shows you how to edit the settings for individual squares. But if you have to produce these multiple times for different speeds and different powers, it's better to use the tool that does it automatically, because that obviously saves you a lot of time. So to begin with, we're going to go up to the square. We're going to come down here and draw a small rectangle. It doesn't matter what size, we'll edit these manually now. We'll come to the top and we'll change this to 8mm, and then we'll change the height to 5mm. Now you can make these whatever you want, but I just find 8/5 works best. If we hit enter, we can now see this is 8mm by 5 down the bottom. You also want to make sure it is on layer 1. What we're going to do now is use the array tool. So if we select this, we have the options to create an array of this rectangle that we've just done. We're going to make it 10 columns wide. As you can see, it updates live down here, and then we're going to make it 10 rows high. We're going to bring the spacing, actually we'll leave the spacing as it is, 3/2. You can alter this, you can make them wider or bring them down, but I like to keep it as condensed as possible to save using too much wood. We'll click OK. Now as you can see, it's drawn us 100 squares that are all on the same layer, and what we need to do is separate these out into separate layers. So we'll select the arrow tool and select the next row up, and then we'll put that onto layer 2, and then we'll do the same for the next layer, and we'll put that onto layer 3, and obviously continue to do this all the way up throughout your grid. 4, 5, and so on. I'll leave it there, but obviously you can manually do this. Now what this means is all these are on the same, each row is on the same layer, and as you can see up here in the cuts and layers panel, it increases the speed automatically for every layer, and as you'll continue to do this, it will do it for all 10 layers. Now the thing is, every layer has a constant power setting of 100, and what we want to do is have the first one at 10% and then 20, 30 all the way up to 100. The way we do this is if we then select all of the items in the first column, I should do that the other way, sorry, from the right hand side, and what you want is the shape properties menu. Now if you don't see this, come up to the Windows menu and you should have shape properties selected here. If it isn't selected, tick it and this menu will appear. Now with this column selected, you'll see that the power scale on the right hand side is showing 100. If we make this 10 and then hit enter, it makes all of that column 10% power. And then in the next one we'll select those and we'll make all of that column 20% power. And then so on for the next one, we'll make that 30% power. And again, you do that all the way until you have a completed item. I'll just quickly finish it off for the purpose of this video. So now we have a full power scale grid produced, and this goes from 10% on the left hand side all the way up to 100% power on the right hand side, and the speed goes from 500 and it should go up to 1400 working its way up. And we've just come over to the cuts layer to double check this, and what we can see is at layer 10 it thinks we're doing something different, so it's got different power and speed settings. We will just change this to match the order of everything else that it should be. So we're going to go, just give it a label, speed 1400 millimeters per minute, and we'll make the speed 1400, maximum power at 100. We'll change it to fill because that's where all the other layers are, and we'll also do it to do the shapes individually. Now the difference here is if we're doing the shapes individually, it will fill every single square individually. If we do shapes at once, it will treat that whole layer as one shape and fill it in at the same time. So we'll do individually just because that's what the other layers are, and click OK. Now it has dropped layer 1 to the bottom, and we just want to make sure this remains at the top for priority order. So we'll select that and we'll just simply use the up arrow on the right hand side to move it all the way back to the top. There we are. Now if we go to the preview, and what we can see is we have the grid of squares, the grid of rectangles that we've just done, and you can see the path that goes between each one. It will just fill every individual box with the different power and speed settings that we've selected. And if I wind this back, you'll see how it will work through them all. Now at this point you can start to label it up by using the font tool and clicking here, and we know that one should be 1400 for example. We'll bring the size of that down, it's a little bit too large, and then you can just duplicate that, copy and paste, and obviously you could then just do that for the whole row. And similarly you would do the same at the bottom under here with the power, so you would have 10%. Again, that's a bit too big, we'll bring that down. And copy and paste that over and do obviously that multiple times for 20%, 30%, and so on until you had all of your labels. Now this is where I was saying this can get quite time consuming if for any reason you need to start adjusting these. If you've done your first test and you find the speeds are too low and then you want to go in and make these all a bit higher, it becomes very time consuming to keep editing all of these different labels and all the different speed and power settings. So at this point I will show you the tool that creates them automatically. So what we need to do now is open up our internet browser and head over to o2creative.co.nz. As always, there will be a link in the description. Now, this website has lots of useful tools. What we're interested in today is the laser tools. So we're going to click on that, and it loads up lots of Lightburn generators. Now there are more complex options that you can work through at a later date. The one we're interested in today is the basic power versus speed. So we're going to click on that. And as you'll see, it displays an image similar to what we just manually created in Lightburn, but this will allow us to do it much quicker and much faster. So as we scroll down, we're presented with a few different options. The first thing I'm going to do is change the speed units from millimeters per second to millimeters per minute. If you're more comfortable working in millimeters per second, then feel free to leave it on that, but for the purpose of my tutorials I always go with millimeters per minute. Next is the power range. Now in the example we just did in Lightburn, we started it off at 10% power and went up to 100% power, so we're going to leave these as they are. The step increment is the gap in between those outputs. So leaving it at 10, it will go 10, 20, 30, 40, all the way up to 100. Again, we're happy with these settings, but if you wanted to do maybe more increments, you could take this down to 5%, or if you wanted to do less increments, you could take it up to 20%, and then it would go 10, 30, 50, 70, 90. Coming further down, we have the speed range. Now you need to have some idea at this point of the speed your laser is capable of engraving at. I'm going to start mine at 1500. I know anything lower than that at 100% really does start to burn the wood. And the maximum speed, I'm going to take that up to 2100. The step interval is similar to the step interval in the power range. So what we want this to do is go up in 100mm increments. So we'll put that at 100 and it'll go 1500, 1600, 1700, all the way up to 2100. Again, you can make this less or more depending on the amount of increments you want within that range. In the label section, you can add a note to the engraving if you wish to, maybe referencing the material or something specific about this test that you're doing. I'm going to leave it blank for today. But on the label power settings, this is still important. If I just scroll back up to the top, the label power settings is about these increments around the edges and this label at the top. Now whenever doing text on my laser, I like to keep the speeds quite low and quite safe, just because my laser doesn't handle lots of fast movements. So I'm going to make this at 40% power, and I'm going to really bring the speed down to about 400 I think. Yours can go higher if you're more comfortable at running it at faster speeds. In the layout section, we want to keep it as rectangle, but there are other options if we want to try different shapes. And we're going to make the shape width, let's say 10mm. We're going to make the shape height 5mm, and we'll make the shape gap 3mm. These are personal preferences and you can set them at whatever you want, but obviously the bigger the number you set, the bigger area it will need to engrave, so you just need to bear that in mind. The layer settings is similar to Lightburn. We have line, fill, or line and fill. For the purpose of this, we're going to do fill. And with the cut order, you can change this to prioritize speed over power, but we're going to go with the first option, which it was already set at. When you click generate Lightburn file, it should automatically create one and download it for you. And there we have it, and we'll click to open it in Lightburn. We should get a message pop up saying where the file was created. There we are, and we'll just click OK. Now I'm just going to zoom out slightly. The first thing I want to do is delete this text at the bottom. I'm not interested in this. Obviously, if you think it's relevant or it's got a reference to the label that you're interested in, then feel free to keep it. So I'm just going to simply drag over this text and hit delete. I'm going to zoom back in a bit now. Now the next thing that we can notice is a lot of the fonts are all bunched up quite tight. Now we've done quite a small grid here. If you did a bigger grid, this wouldn't be an issue because everything would be spaced out more, but what we're going to do is bring the font size down a little bit just so that everything has a bit more space around it. Now you could manually drag over everything or hold down shift and click individually on all the different items, but that takes time. The advantage to everything being on the same layer, and this is indicated by them all being in the same colour, is we can come up to this particular layer, hold down shift and click it, and it highlights all of that text together. So now we can come up to the height option for the font, and we can bring this down to maybe 6, and let's see how that looks. It's still a little bit tight where we've got the 90 and the 100, but I think I'm happy with that, and it saves going too small. Now if I come up to the preview, what we'll see, we've got all the shapes and the text and the cutting paths highlighted with this red line, and if we bring this back to the start, you'll see that it does all of the labels first as it is in the layer priorities, and then it will start to do the boxes, but as you can see it's engraving all the boxes individually. Now this creates a lot of traverse movements and I want to minimize those down. This again is personal preference, but I'm just going to show you the difference in what I do. So I'm going to go into one of the layer settings, and rather than fill shapes individually, I'm just going to select fill all shapes at once. Click OK, and I'm going to quickly do this for every layer. And if we go up to the preview again, we'll now see that all these are joined by red lines, and as I wind this back, rather than doing boxes individually, it is doing rows as one collective. And this simply means there are less traverse movements, so therefore it's putting less pressure on the motor to keep sending the laser back and forth every time. There are advantages to doing boxes individually, but I think the advantages of doing it this method outweigh those other advantages. So we'll click OK at that point. Now I'm pretty happy with the powerscale test, and I think it's ready to connect the laser and get this engraving. So if we turn the laser on, Lightburn should connect to it automatically. You might just hear the fan kick in of the laser then. So to test that Lightburn is connected, we're going to come over to the console section, and we can already see that it is connected, but let's just double check to be safe. We'll type in $$ to pull through all of our settings. There we can see it is connected and it's pulling through the correct settings. I should mention at this stage that the maximum speed you have set in your test should be no higher than your $1.10 setting or your $1.11 settings. If it is, you will not achieve this top speed. This is the maximum speed that your machine will output. If you haven't already done so, go through my tuning GRBL settings, link will be in the corner. So now we're going to come over to the Move tab. And we're just going to fire the laser up at 1% to try and roughly position it in the corner of the wood. Obviously at this stage, make sure your enclosure is closed or you have safety glasses on. Now we're going to position this, move this over a bit. I'm going to make this 10mm. Let's move it to the left. And again. And bring it back a little bit. Maybe left again. A little bit too far. I'm just going to take it down to 1mm and pull it back in. And pull it back a little bit. Now we're going to turn that off. Now we're going to check the height of the Z by placing my depth stop in, and we're going to lower the Z down until it touches that. If you're not familiar with this, again go through my previous tutorials for setting up your laser and it will show you what this is about. There we are, it's just about touching it now, so we'll take that out. And we're good to go. We know that start from is in the current position, which means it will be starting from this green square rather than the red square, which is the origin for the actual workspace, which is what we want. So now we should be able to click start and this will begin engraving. We know it's within the bound, so we will continue. And at the end you should have something that looks like this. Now the gradation is pretty good on the lateral and going upwards. As you can see, there's almost a diagonal gradation going on. Unfortunately it does start to drop off around the 20%, and there's certainly nothing catching in the 10% column. Now I based this lowest speed on a previous test that I'd done, but this is the first time that I've ever used Baltic birch. If I show you the previous test on a different type of plywood, we can see the 10% was just about catching at 1500. So what I'm going to do is rerun this test but at a slightly slower speed, maybe bring the speed down to 1400, 1300 and 1200 just to see if we can get the 10% to catch. You may also notice these burn marks on the edge here. This is just proof that it doesn't always go right for me, as these were mistakes, but luckily enough we still managed to burn the powerscale test. So we've just generated a new test at lower speeds. I will just highlight, in order to get this to 1400, for some reason on the O2 Creative site I had to put the speed up to 1500. I'm not sure why this is, it may just be a slight glitch in the generator, but if you do come across that, just take the setting up one and you should get the speed that you're after. Now coming back to this, what I've also done on this version is turned on the overscan. So I'll just open this layer up and you can see we've turned overscan on, and I've took this up to 4%, so it should just overshoot the square slightly. And if we bring on the preview and zoom in here, as you'll see, it just shoots past where we want it to engrave, and that gives it time to slow down and re-accelerate back up to speed before the overburn should kick in, and hopefully that should minimise some of that charry soot down the right hand side that we had. So I'm going to quickly engrave this now and we'll check back in on the final product. So with that second test done, we can see that 1100 millimeters per minute we was getting a shading in the 20% box, and the camera can't quite pick it up, but we are getting something in the 10% as well. However, above these speeds it starts to fade back off again. And this just goes back to my point about the diode lasers having quite a significant drop off after a certain percentage in the lower end of the scale. The downside to these slower speeds is it means the higher powers all start to look a similar colour because there's too much burning going on. So I think after doing both of these tests, my ideal speeds are probably going to be somewhere around the 1500 to 1700 mark. More than likely the 1500 because we get a little bit more shading in the 20% area. Now the next type of test we're going to do is loading in the raster grayscale image to see how it interprets it. And the reason that we're doing two separate tests is the first one, we are literally telling Lightburn that this box is 10%, this box is 20, this box is 30, and so on. On the next grayscale test, we are seeing how the software interprets the different shades of colours. So what I'm going to do is just select everything quickly, hit delete, and then we're going to come to File, Import, and I'm going to load a file off my desktop, which is just a raster grayscale image. You probably can't see that clearly on screen if I zoom in slightly. You'll just see that this is a full graduation going from 5% all the way around up to 100%, and then a smooth graduation on the side. And we're expecting the laser to output this as close as possible, but as we've just seen, we do have a drop off point somewhere around the 25 to 20%, so I would expect to see the same in this, and perhaps the 5, 10 and 15% may not be shaded. Now the size of this images are down the side. Lightburn does load it in automatically at the correct size, and as always the files will be provided in the description and the link below. Now I'll zoom back out. So I will mention, although this looks like it's made up of lots of different components, because it's imported as a raster image, Lightburn treats it as one graphic. We can't go in and edit any of these components. And it also means that when it comes to engrave it, it will do it line by line to the full width. It will not be able to break it up into any separate segments. And I can also show you that if we come over to shape properties like we did when we were doing the true scale test, we have a few options to be able to adjust this individually. You can go in and play with the brightness, play with the contrast and a few different settings. For the purpose of this, I'm leaving everything as default because we don't want to alter the image. This is a true grayscale image and we want to see how it comes out. And the next thing we'll do is head up to the cut and layers panel. Now as we can see, as we've loaded that image in, it's already selected the mode as image, and I will double click on this now to load more settings. Now we just went through the speed test, so what I want the speed to be at 1500, and we're going to put the power at 100%. Now I wouldn't normally do the images at 100% just to save using too much power in the laser, but for this test purpose I'm going to. So we'll put that in as 100%. And as we come further down, we've got a few different options for how it's going to interpret the image. And we have a live example of what the different methods will do below. The main ones that you need to focus on are the line interval, and this is going to be how crisp and sharp it tries to do the image. At 0.1, basically what that means is we will get 10 lines per millimeter. And if you're talking about this in a print range, that will give you 254 dots per inch. And when we come down to the image mode, we have quite a few choices of how it handles it. Now I'll just quickly show you some of them, and as you can see, that's a stark black and white interpretation. Then we've got a few different options for how it interprets a dither and the way the algorithms do the dots. And then if we come down to something like Jarvis, which is quite a popular dither option, and you'll just see that there's no particular order to the dots, but it will give a smoother graduation. Now what we're interested in today is the grayscale. We want this to be as smooth as possible in the way it interprets it, just to try and get the best results that we can. So with that selected, we will click OK. Now we don't need to reposition this anywhere on the artboard because we already have the start from current position set, and that means it will start from wherever we set the laser to, because it's going to work from that green square in the bottom left hand corner. So what we'll do now is start the laser back up. It's going to turn on the fire button. We'll try and get close to the edge. We can bring that back a little bit more. There we are, that's close enough. I'll turn that off now. And we're good to start the job. The depth is already correct because obviously we've already done several tests, so we'll click start, click yes to the out of bounds prompt, and let's get the job started. And there we have our raster grayscale engraving done. Now we can see we've got a good graduation all the way around to around 2/3, and it starts to drop off just after the 30% mark, which is a bit earlier than the previous test, but it still gives us a good range, and we can clearly see that because the 4 different quadrants here each have quite a good definition, and the scale on the side gives the full definition as to where we can expect it to drop off if we were converting a grayscale image ready to engrave. So these grayscale tests don't actually resolve any of the drop off, but it does give us an indication of where it's going to happen for future projects, which is really useful. Now I have been told about methods to improve these graduations, such as highering or lowering the laser so the focal point is not perfectly on the wood. Also using bicarb soda mixed with water. You spray that on the wood and then laser straight away, and it's meant to give you a better result, but we'll save that experiment for another episode. So hopefully at the end of those 2 tests you'll have a great graduation going on, and it's a brilliant indication of what speed and power settings to use going forward on future projects, whether you're telling Lightburn what the power settings should be or whether you're hoping it will interpret it when you're doing something like a photo engraving. And please do remember, your settings and outputs may not be exactly the same as mine. Every machine is individual. Now there are a couple of things I didn't mention during that video. The first is that whenever you're doing any type of laser engraving, try and have some form of fan or air assist working at the same time. It will just help get a better quality on the burn. You can use something as simple as this hand fan and just rest that near the laser while it's burning, or something that I would try on a future project is actually a fish tank pump, and you just locate the nozzle close to where it's burning. That should blow all the smoke away, and as I say, get a cleaner cut. Now that is the end of today's episode. I really hope you enjoyed it, and it gives you a great reference to use going forward. As always, if you enjoyed it, please give it a thumbs up and subscribe to the channel. If you found the content helpful, please consider donating through one of the links below. That is everything for today, and I'll see you on the next episode.